The factors EC and EW are required to calculate the limits in X charts. How these factors are calculated for any sample size is shown in this lesson. And hello again to this lesson, which essentially has two learning objectives. By the end, you should have understood how the sample size is related to the probability that there is a limit violation. Furthermore, you should be able to calculate the factors EC for the calculation of the control limits and EW for the warning limits for any sample size. This lesson is divided into 3 chapters. The first chapter briefly repeats how the control charts for a sample size of 1 differ from those for a sample size greater than 1. The second chapter is, so to speak, the preparation for the actual calculation of the factors EC and EW, which then takes place in the third chapter. Let's revisit the differences between an X chart for a sample size of 1 and an X chart for a sample size greater than 1. You may already be familiar with this plot from the lesson on designing an X chart for any sample size. Therefore, here is just a brief summary. The starting point is always to choose a non-interference probability in the process. For example, 99%. This means that if the process is in control, it can be assumed with the probability of 99% that the actual values of the characteristics produced are within the limits. With a probability of 99%, there is no need to interfere in the process. The following can be derived from the multiplication theorem of probabilities. The larger the sample size, the greater the individual probability must be that an individual value is within the limits. Because the overall non-interference probability, 99%, is calculated from the product of the individual probabilities. With 5 values, the individual probability P1 is 0.99799. 5 times 0.99799 results in P total, which is again the non-interference probability of 99%. This also makes it possible to make the further statement that the larger the sample size, the wider the limits must be. So that should be enough for now. If you want to delve deeper into this, be sure to check out this lesson on how to design an X chart for any sample size. Let's now prepare for the subsequent calculation of the factors EC and EW. Essentially, we will repeat the following 4 steps. We look again at the value curve and the histogram as a starting point for understanding the value distribution. We will again discuss the probability density as the mathematical basis for determining the quantiles for the special case of a sample size of 1. And we take a closer look at the formulas used to calculate the warning and control limits, because in these, the sought-after factors EC and EW find their application. So, once again, for the calculation made here, we assume that the values are approximately normally distributed. The representation in a histogram offers a good first visual orientation. The distribution of the values is described mathematically using the probability density function. The area of size 1 minus alpha is the probability that exactly one value will fall within the upper control and lower control limit. As can be seen in the formulas shown on the left, the values for the control limits can be calculated with the quantiles of the standard normal distribution or with the EC factor. The same applies to the calculation of the control limits for larger sample sizes. However, the question arises as to how large the quantile U or the factor EC is. These depend on the sample size itself if the non-interference probability is fixed. To make it a bit clearer, where the non-interference probability is found in the formula. The expression 1 minus alpha n given on the left in brackets stands for the non-interference probability. For example, 99 or 95%. The small n in alpha stands for any sample size. However, the limits should be selected in such a way that exceeding the limits by just one value always provides a signal for an out-of-control process. Therefore, the question now arises: how large is the individual probability that a value is inside the limits given a sample size of n? We had already talked about the multiplication theorem of probabilities in the preparation. The next chapter will be about finding the quantiles, these are the factors EC and EW, for which the control chart delivers a signal if one value is outside the limits. That is, if the non-interference probability of 99 or 95% was violated. And this brings us to the next chapter, in which the factors EW and EC are calculated and tabulated. The goal is to enable us to create the table shown on the left ourselves. This contains values for the factors EW and EC for the non-interference probabilities of 95 and 99% depending on the sample size. To do this, we will proceed as follows. First, find an expression for alpha. Then substitute this expression into the general formula for the upper control limit and simplify. Create this formula for the concrete probabilities of 95 and 99%. Then calculate the non-interference probability for a single value for a sample size of 5 in order to then determine the associated quantiles with the help of the standardized normal distribution. As a final result, we then get the table shown here with the factors for EW and EC. So, let's start finding the expression for alpha. We will continue to carry the general applicable formulas on the left with us. The underlying question to be answered is: given a sample size of n, what is the single probability that a value is inside the limits? 1 minus alpha n is the non-interference probability for a sample size of n, where alpha n is the probability that n values are outside the limits. To find the single probability, we apply the multiplication theorem of probabilities. The following equation results. As already mentioned, 1 minus alpha n is the non-interference probability for a sample size of n. The expression 1 minus alpha stands for the non-interference probability for a single value. By transposing to alpha, we get the double underlined expression for alpha, which we need for the further calculations. The expression which we just found for the probability alpha is now put into the formula for the upper control limit. This so found formula could be used directly, but we want to further simplify the formula as done here. If you want to understand the calculation in detail, you should pause the video at this point. In any case, by simplifying the formula, we obtain the below expression, which is double underlined. With the formula that has just been found, the non-interference probabilities can now be calculated specifically for an individual value. For this, the overall non-interference probability in the process, for example 99%, must be specified. This is exactly what happened here as an example for a sample size of 5. For this sample size, the relative non-interference probability for one value is 0.99899959, and for the warning limits 0.9948968. Based on these values, the factors EC and EW are then calculated. The quantiles, or the factors for EW and EC, can now be determined with the help of the already known table of the standardized normal distribution. To do this, look for the closest value for the non-interference probability in the table. For the control limit, this is 0.999. The resulting factor for EC is 3.08. For EW, we get for the probability of 0.9948 the factor EW 2.56. A more precise calculation, for example with the Excel function norm.s.inf or norm.dist for different sample sizes, results in the following table for the factors for EC and EW. Tables like this can be found in the relevant specialist literature. Finally, here is a practical example. The corresponding limits are calculated using these factors for EC and EW and the formulas given below for the warning and control limits. This has been done here, and the warning and control limits have been drawn on the control charts shown on the right. The 95% warning limits are 60.19 and 60.03 mm, and the 99% control limits are 60.2 and 60.02 mm. Exceeding the control limits by just one value is a signal that a process may be out of control. A check is necessary and a readjustment may also be necessary. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 3 most important key messages. With X charts for a sample size of 1 and greater than 1, the probability of non-interference in the process should be the same, for example 99%. The limits are calculated for the probability that exactly one value is outside of them. If one value exceeds the control limits, this is an indication of a possibly out of control process. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care and see you next time. Bye!